Hello friends, welcome to Dhaka 11 Institute. Today I am going to discuss about desktop power sequence. It is very important for those who are interested in desktop repairing. Today I am going to discuss about that. First of all, I am going to introduce with you the important parts of desktop. First is CPU, this is also called processor, place, and another is not this, it is also called GMCH or graphics chip, and other is South Bridge, it is also called ICH or main chips, and you can see there is SIO, it is also called SIO, IO, EC or KBC, and we can see there are colorful dots. These colorful dots are meant to be ATX connector ports. Here power supply connectors are joined here, and I'm going to discuss all the process in details of desktop motherboard power sequence. First, when power supply is connected with power cable and with the motherboard, then there is a voltage enter into IO chip, and this is 5V SB or 5V standby. It will come from this wire, and when IO will get that volt 5V SB, and if IO is okay, then IO will pass a signal named RSM RST that will enter into South Bridge, and South Bridge also get crystal frequency if crystal is okay and get and provide frequency, and if CMOS battery pass voltages, and if the RTC section is okay, then South Bridge is confirm okay. When we will press power button, then I will get the power button signal, and then I will pass the signal power button out to South Bridge, and after having all the frequency and voltages, South Bridge will pass SLPS3 and SLPS4 signal to IO, and then we can see there is green wire is here, and there will be 5V here. When power button is pressed, then the 5V, this wire voltage will be low, and the low signal will be into IO chip, and then all the voltages 3.3V, 5V, 12V will be activated. First 5V will pass from 5V side wire, that will first go to RAM section, as it is DDR2 RAM board. The RAM section will provide 1.8V, and then 5V will also enter to this linear regulator, and that 5V will be converted into 1.25V, and it will enter into North Bridge, and then we can see there is 1.8V from RAM section that will enter into a linear regulator, and it will convert 1.8V into 1.1V BTT. It will go to North Bridge, and 1.1 around volt will go into CPU 2, and if these are okay, then this whitish or gray color wire will provide power OK signal to I/O, and meanwhile or already BRM section will get 12 volt from these 4 ports connector. BRM section will get 12 volt, and then there will be BRM signal from I/O and other parts, and there will be other signal from I/O to south bridge, that is power OK signal, and then there will be CPU core voltage BRM section will provide after having power and signal. Then CPU core voltage enter into CPU, and when CPU will get the power, then CPU will provide BRM power good, and it will also enter into BRM power good to south bridge, and then BRM section will enable BRM IC will enable clock IC, and clock IC will generate pulses, clock signal to all the required parts, and CPU clock also enter into CPU, and then CPU will generate BID to BRM chip, and then south bridge will also provide CPU power good to CPU. Then south bridge will pass PLT reset to I/O, and it will also pass PLT reset to north bridge. It is very important signal. If it is okay, if this signal is okay, then you can see that everything is fine. Then south bridge will provide PCI reset, and then north bridge also provides CPU reset to CPU, and last of all we can see there is BIOS IC, and south bridge or main chip will communicate with BIOS, and if data communication is successful, then we can see that everything is okay, and display will be shown, and everything is okay. So if there is any problem in any path, any step, then all the system will not be performed perfectly. If we can see that, suppose if there is no SLPS3 or SLPS4, then you can say that south bridge is faulty for any reason, and if RSM reset RSM RST is not provided to south bridge, then you can see that you can say I/O is faulty. And there is also many things are here. If CPU reset is not confirmed, you can see that north bridge has problem, and if you doesn't have CPU power good, then you can say that there is problem on south bridge. And if you do not have BID signal, then you can see there is problem in CPU. And if BRM chips doesn't provide BRM power good, then you can say that BRM section has problem. So you can understand now how you can troubleshoot desktop motherboard. So I think I have made you understand all the things. Thank you. Hello friends, welcome to Dhaka 11 Institute. Today I am going to discuss about clock generator section. This is very important class today, though this class will be very short, but this class is very meaningful because sometimes we get some motherboards with no display problem, but we find out that this problem has been created, problem has been happened from clock section. So this clock section is very important. So today I am discussing about this, and we can see this is desktop motherboard 2480X connector port, and in 13 pin there will be 3.3 volt, and this bolt will enter into this clock IC, and when this clock IC will get voltages, power, and this clock IC will be activated, and then when this clock IC will be activated, there will be crystal frequency, and there must have crystal frequency, because without having or without getting crystal frequency, this clock IC will not be activated and clock will not be generated. So this crystal is very important. This crystal should be okay, otherwise this section will not be activated. So, and there will be display problem, no display problem. Okay, so when this IC will get crystal frequency, and there when we'll try to measure the voltage, will get 1 to 2 volt, and there in one side you will get some voltages, in other side there will be less voltages. Then we can understand that this crystal is okay, and after getting frequency, then clock IC will actually pass clock to the other parts of motherboards. Clock is very important. So we can see that there are a lot of chips are here. All the chips are very needed of getting clock. So clock signal is very important. So CPU is needed, clock, LAN IC, NOT bridge, South bridge, RAM, BIOS, IO chip, and PCI slot all should have clock. And after having clock signal, then all the chips will be activated. Without this clock, there will be problem, no display problem. So clock section is very important, and we always have to be very careful about this. And if we are good enough to measure the clock, so we have to use the CRO, then we can measure the clock signal. And without CRO, we can also actually measure by multimeter. We can get 1 to 2 volt, and this clock IC will actually generate 1 or 2 volt clock signal to all these ICs. So after having that voltages, then we can say that all the ICs and the clock IC also fine, clock section is fine. So that's all. Thank you for watching this video, and Please subscribe my channel and share and like. And hello friends, welcome to Dhaka 11 Institute. Today I am going to discuss about desktop motherboard audio section. This audio section is very important because nowadays customers are bringing their desktop motherboard for audio problem. So this section is very important for those who are interested in repairing desktop motherboard. So I'm discussing today, and first of all we can see there is a diagram, colorful diagram. This is actually desktop motherboard 24 ATX connector. So here from power supply there will be joined, a connector will be joined from power supply. This is there are a lot of wires, colorful wires. Actually these wires, colorful wires, will generate voltage as signal or any other, maybe ground. So from these colorful ports we'll get the voltages and signals. In audio section, first there will be plus 12 volt from ATX connected to this regulator, and this plus 12 volt will be converted to 5 volt, and then it will enter into audio IC, and audio IC needs another voltage that will be entering into audio IC from ATX connector number 1 pin, and this 3.3 volt is entering as VCC. So we can get these two voltages. These are the main voltages of audio IC. These voltages are very important for power on this IC, and then the audio IC will communicate with south bridge, and it is very important. The communication is very important, and communication will be successful if south bridge is good or audio IC is good. Then they will communicate each other, and after communication, and then audio IC will give output, and this output will be to audio port we have in our CPU casing backside. We can get that port, and then there is input and there is output. So this audio IC will pass these connection, these signals, these voltages, whatever you say, after having these voltages and after having communicated with south bridge. So these steps are very important, so we have to understand before repairing desktop motherboard. So we'll have to test first, and then we have to test in hot. So this desktop motherboard audio section is very important for repairing desktop motherboard. So I hope you understood. Thank you very much for watching this video, and please subscribe my channel and like and share this video, and stay with me. Thank you very much. Hello friends, welcome to Dhaka 11 Institute. Today I am going to discuss about block diagram of power switch logic or PSL. Power switch logic is very important for repairing any laptop, because for knowing the state of the laptop you must have the knowledge of power switch logic. So it's very important. Now I am discussing about this. So we can see that there's a charging IC, And first of all, when you will insert an adapter, there will be a signal, that is SEOK hash or SIN hash. This signal will come by a register to IO named PSL in 1, and that will be low, as I told you before, that SEOK hash or SIN hash means there will be a low signal. Okay, and on the other hand, there will be other signal that will come after pressing on off switch, and this signal will come by a resistor 2, and after this resistor there will be 3.3 volt, and this PSL in 2 will be high, that will enter into IO chip, and there will be actually communication with BIOS, and if the communication is successful, and then there will be a signal, PSL out signal, and RSM RST hash signal. These signals will be low. Okay, then if everything is okay, and after foot number step there will be the last step, we can say, that is SLPS 5 hash or SLPS 4 hash. Both this signal will come from PCH or SOC, and then it will enter into IO chip. So these signals are very important. After coming this signal, you can say everything is okay now. This power switch logic will be accurate, and that will work okay, and I will make you understand how this logic will work. And actually in this IO there will be a comparator that will work first like low, high, low, and as you know, as I told you before, that first SEOK hash or SN hash signal will be low, PSL in 1 will be low, and then PSL in 2 will be 3.3 volt, or that means there will be high, and then again you can say that the output is low, PSL out is low. Actually there is a comparator internally, there will be working like that. I will tell you that in that signal SEOK hash or SIN hash, there is PSL in 1, and this will be low, and in input side of comparator, first input will be PSL in 1, that will be low, and then again we can see in one of switch there will be 3.3 volt, and in other part of that inputs there will be high. So okay, this comparator is AND gate. So if you want to make output high, there should have two high, but there is one high and one low, so output will be low. Okay, so that's why this logic is working like that. This is low and this is high, and as this comparator is AND gate, so high and low there will be output low. Okay, so this was the power switch logic. Thank you very much for watching. If you like this video, please subscribe my channel, stay with me with hitting like and bell button, and make comments for being connected. Thank you. Hello friends, welcome to Dhaka 11 Institute. Today I am going to show you most important discussion, that IO triggered stage. This is very important for who wants to have service, especially laptop servicing. So IO trigger is very important. So today I am going to discuss about that. So first of all, you know that for working IO, so there are some voltages. First of all, it will actually be in, and then IO will make the voltage out. Okay, so first of all I will try to start the first step, and then I will show later on all the steps of the IO trigger. Okay, so First, now I can see there first there will be VCC volt, and the volt will become from uh, 3 volt 5 volt IC, and that volt will be 3 volt 5 LDO, and and that will come to IO, and then there will be another volt, that is ABCC, and this is also 3 volt LDO, and that has been named ABCC. And another thing is that, and both of them have actually two ground. One is GND and another is AGND. Okay, GND for BCC and AGND for ABCC. So we can see that there are two voltages are here, which in already in IO, and then we can see another LDO voltage will be in IO, 3 volt LDO. It has been pulled up. Actually, there is a resistor. By resistor, this voltage has been pulled up. Okay, so then we'll see another one, and this is very important thing here, and we can see that this is the work of lead switch or Hall switch. Okay, so there is a impact of lead switch and Hall switch in IO, and this switch voltages and its signal will come to IO, and here will be 3 volt LDO pull up. Okay, and the lead switch hash signal will be in IO. Okay, and you can see there, and there is another stage, that is there will be other 3 volt LDO, and we can see that there is voltage divider, and there are two resistors are here, and by this resistor 3 volt have been divided, and there is a voltage will go to IO, and actually these two resistors are called thermal protection section, and this is very important section. Later on we will discuss about that. Okay, so and then we can see another thing, that is very most important thing is there, and actually IO will function when after there you can see there is a crystal. When crystal actually pass the frequency, then IO will perform other parts. Okay, other things, and after having crystal's frequency, then there will be that lead switch or Hall switch hash will be passed, and it will be the first output, lead switch out. Okay, and then will be most important thing, that is that on the work of on off switch, and when you will press the on off switch, then there will be already, as you know, that there will be already 3 volt LDO, 3.3 volt, and also there will be 3 volt LDO, and it has been pulled up, and when the on off switch will be pressed, then there will be a signal that is called power button hash or NBS on hash. Okay, so after this signal getting, the IO will pass another signal, that is the DNBS on hash. Okay, and it will go to ICH or PCH, and then there will have communication with BIOS. IO will communicate with the BIOS, and after communication success, then there will be the last part, that is RSM reset. Very important, important signal that is, and after getting this signal, you can say that total IO supply and IO signals also are okay. Okay, this is okay condition. You have to check this RSM reset signal. Okay, so now we can see there the first uh, stage is there will be 3 volt LDO VCC, and then second will be ABCC, and there will be their ground GND and AGND, and fourth will be 3 volt LDO by pull up resistor, and then the work of Hall switch and pull up by 3 volt LDO, and then the next will be 3 volt LDO with voltage divider, and that is called also thermal section, thermal protection section. And then the seventh is crystal frequency, that is very important for IO. After having frequency, then the IO will pass the other voltage, other signals, voltages, okay, out. So then the another is number 8 is lead switch out, and 9th is the work of on off switch. After pressing the power button, then the 10th, that is NBS1, will be signaled, will be out, and the 11th is the BIOS communication, and the last one is the RSM reset. Okay, and then the process switch is complete, and it is the IO trigger stage. And thank you very much for watching this video, and I think it has been helpful for you. It will be helpful for you, and please subscribe my channel and like and share. Thank you very much for watching. Stay with me and make a comment. Thank you very much for joining.